Need to add custom headers, logging, or request tracking to your FastMCP server without rewriting your entire handler logic. Here, how to create lightweight middleware that wraps every request with pre- and post-processing logic, all while keeping your core operations clean and focused. You'll see how to intercept requests, log their progress, and modify responses, all in just a few lines of code.
From FastMCP server middleware, import middleware, middleware context. Class custom header middleware, middleware. Async def on request, self context, middleware context, call next. Hash add custom logic here. Print f processing context method. Result equals await call next, context. Print f completed context method. Return result. MCP, add middleware, custom header middleware.
This demonstrates the middleware pipeline pattern, a chain of responsibility implementation for cross-cutting concerns in RPC systems. The pattern intercepts requests and responses at multiple stages, allowing you to inject logic like logging, authentication, or transformation without modifying core handlers. What makes this distinctive is its non-invasive nature. Middleware wraps existing functionality rather than requiring code changes to individual tools or resources. The pipeline works by composing layers of pre-processing and post-processing around each request. Each middleware receives the context, can modify it or short-circuit the chain, then delegates to the next layer via call next. This creates a clean separation where infrastructure concerns, like timing or rate limiting, live in middleware, while business logic stays in pure tool implementations. The execution flow remains linear from the caller's perspective, even though multiple layers may inspect or transform the request. This approach solves the problem of scattered cross-cutting logic in RPC servers. Instead of duplicating authentication checks or logging code in every tool, you centralize it in reusable middleware components. The trade-off is slight overhead from the pipeline, but the benefits, cleaner code, consistent behavior, and easier maintenance, make it ideal for production systems where you need to enforce policies across many endpoints. Let's break it down.
From FastMCP server middleware, import middleware, middleware context.
This imports the base, middleware, class, and middleware context type from FastMCP's server middleware system. These provide the interface for intercepting and processing requests, enabling cross-cutting concerns like logging or authentication.
Class custom header middleware, middleware. Async def on request, self context, middleware context, call next. Hash add custom logic here. Print f processing context method.
This defines a middleware class that intercepts and processes requests before they reach the main handler. The onRequest method runs custom logic during the request lifecycle, here simply logging the HTTP method being processed. Middleware pattern enables cross-cutting concerns like logging, auth, or request transformation without modifying core handlers.
Result equals await call next, context.
This delegates to the next middleware in the chain using call next, preserving the middleware pipeline pattern. The await ensures proper async execution flow, allowing downstream middleware to process the request before control returns. This is the standard FastMCP middleware chaining mechanism, where each middleware wraps the next in sequence.
Print f completed context method. Return result.
This logs the completed request method and returns the processed result to the client. The pattern ensures middleware can both pre-process requests and post-process responses, maintaining the full request-response lifecycle visibility.
MCP, add middleware, custom header middleware.
This registers the middleware with FastMCP's request pipeline. Middleware intercepts every request, allowing you to add cross-cutting concerns like logging, auth, or request transformation without modifying individual handlers. The pattern enables clean separation of concerns while maintaining control over the request lifecycle. Middleware Interop Pattern. The custom middleware example demonstrates FastMCP's chain of responsibility architecture, where each middleware processes the context before optionally delegating to the next handler via callNext. The middleware context is immutable during processing, so any modifications require creating a new context instance with your changes. This pattern enables cross-cutting concerns like logging, validation, and transformation without coupling them to specific tools or resources.
The middleware that handles everything handles nothing, while the middleware that handles nothing handles everything.